This is the solution to math problem number 39 from the SAT 2 level practice exam. You have a sequence, and it's called a recursive sequence, which just means that, well, maybe take a step back here. A sequence is a list of numbers, and you could just think of them as blanks for now. In this case, the first term in the sequence, or the first number in the list, it's designated as A sub 1, subscript 1. And that first number is -1. Now it's a recursive sequence, which means that subsequent terms, or numbers in the list, will be based upon the previous number. So let's take a look at what A subscript 2 might look like. That means the second number in the sequence is A sub n minus 1, which is 2 minus 1, times -1 to the nth power, which is 2. So what is this? Well, A sub 2 minus 1 is A sub 1. -1 squared is 1. A subscript 1, well, that's -1. That's the first number in the list. That's because this part of the recursive sequence formula tells you, hey, look at the term immediately preceding this one, multiply it by -1 to the nth power. So that's -1 times 1, which is -1. So the next term is -1. All right, we'll try the third term. The third term is, take a look at the term previous, -1. Multiply that by -1 to the third power. -1 to the third power is -1, times -1 is 1. So we're starting to generate this list. We'll keep going with this. A sub 4 is the previous term, times -1 to the fourth power. And that's going to be 1 times 1, which is 1. So maybe I should do a better job of keeping track of this list. So A sub 1 is -1, A sub 2 is -1, A sub 3 is 1, A sub 4 is 1. And we start to anticipate maybe a pattern developing. -1, -1, 1, 1. Let's take a look at A sub 5. That's the previous term, which is 1, times -1 to the fifth. -1 to the fifth power is -1, -1. So it sure looks like a pattern is developing. And indeed, you could prove that. Of course, in the SAT, you want to use your time wisely and maybe check one more time and see if indeed that is the case, that we've got a pattern happening here. -1 times -1 to the sixth. Remember, the even exponents are going to make that value positive. Then this value is negative, that value is positive, negative. In this case, it's going to be positive. So -1 times +1, -1. And so this sequence goes in pairs. -1, -1, +1, +1, -1, -1. And we'll actually kind of write out the list here. So we have n, which is the term. 1. We're only going to the 11th, so we could just list them out. And so when n is 1, the first term is -1. That was given. Then we start to develop this pattern. -1, -1, 1, 1. -1, -1, 1, 1. -1, -1, 1. So the 11th term is +1. That is choice E.